Certain figures and graphs allow us to determine the amount of errors in our readings as well as their precision and accuracy. Let's look at the error boards over here. Let's assume that each shot made on the board represents a reading taken, and that the center of the board itself represents the true value. If we were to first look at the grouping of the readings for the first and second board, because the readings are close to each other, we can say that the scatter is small, which in turn gives us a high precision but low random error. And then looking at the third and fourth board, we can see that the readings are actually far apart from each other. So the scatter is high, which in turn leads us to have low precision but high random error. Now, let's look at the point where the readings are centered about. The point where the readings are centered about can be thought of as being the mean value. For the first board, is probably around here, second board around here, third board around here, and for the last board, probably around here. Now, for the first and third board, notice that the mean value is close to the true value. Our degree of skewing here is actually small. This in turn gives us a high accuracy, but low systematic error. Now looking at the second and fourth board, we can clearly see that the mean value is far from the true value. So the skewing here is considered to be high. So our accuracy is considered to be low, but systematic error is considered to be high. You may have noticed a relation here now where we can say that precision is inversely related to random error. If we say that the precision is high, that means the readings are very close to each other, the degree of scattering is small, our random error is small. Conversely, if we say that our precision is low, that means the readings are very far apart, the degree of scattering is very large, our random error is going to be large. Now, we can also say that accuracy is inversely proportional to systematic error. If our accuracy is high, that would mean that our readings are close to the true value, our systematic error is low. On the other hand, if we say that our accuracy is low, that means our readings are far from the true value, our systematic error is high. In our next example, we have a set of graphs that show us the number of readings and their corresponding lengths. Let's first assume that the red line represents the true value of the lengths. Whereas the dotted line representing the length value with the highest number of readings is actually the mean value. From here, we will be able to deduce the accuracy of our readings. If you look at the first graph and the second graph, you will see that the mean value is far off from the true value. So we would say that the accuracy is low. If we were to look at the third graph, the mean value is close to the true value. So the accuracy here is high. And for our last graph, the mean value is at the true value itself. So the accuracy here is the highest. Next, we look at the scatter or range of our readings indicated by this orange line here. For the first graph and the third graph, you can see that the scatter or range is actually quite large. So we would say that the precision here is low. Whereas for the second graph and the fourth graph, we can see that the scatter or range is actually lower. So our precision here is high. In our last example, let's consider a relation y equals to kx. We measure y for different values of x to plot a graph. If our relation is valid, we should get a straight line graph that passes through the origin. If our measurements have no errors, there are no random errors, no systematic errors, we will get a graph that looks like this. All the points will form a perfect straight line. On the other hand, if we have random errors, all the points would be scattered about your best fit line. So if you see that there is a scatter of points about the best fit line, you would say that there are random errors. Now we move on to systematic errors. Recall that earlier I said that if your measurements do not contain any errors and that the relation is valid, you will get a straight line graph that passes through the origin like this. If your measurements instead give you a line like this, you would say that there is systematic error because all your values here are above the true value. You might also get a line that is below the ideal line. You would also say that there is systematic error here because all the values are below your true value.